Okay, perfect. Yeah, thank you very much for including our paper to this wonderful conference. So in this paper, we essentially look at some spatial feature in the process of a structural change, and then try to understand how that's going to affect the marriage market, both kind of in aggregate and also in different locations. So the kind of a broad background, we see the fertility rates and the marriage rate and fertility both are declining around the world. This is a graph for China. So from 2010, both the marriage rate, that's the blue line, and fertility, red line, less than 15 years, almost dropped by half. So it's very quickly decreasing. And the kind of the motivation that we try to start this paper is that we look a little bit more closer, and we find a clear and interesting spatial feature in the marriage rate across different locations. So in this map, what we calculate is the difference of the singles rate between men and women in each cities. And then if it's larger, there are going to be more red areas. Those are places where men has much higher. So those are places men has much higher singles rate than women. And those red regions are typically inland provinces, inland areas that are less developed and typically have large population outflow. And for those regions with they're more blue, those are the places that have much more single women than men. And those regions are typically coastal areas, more developed, more urban. So you see there's across the space, there's kind of a mismatch in each local marriage market. On the one end, there are more single men and women. On the other end, there are more single women and men. Later, I'm going to show you a little bit more detail about the data that those single women in more developed regions are more high skill. And those single men in undeveloped regions are relatively more low skill. So in this paper, we're trying to argue essentially from a spatial equilibrium perspective, we just think that these two phenomena just happen at the same time and they're driven by the same forces. The idea is essentially, if you think about the jobs in marriage, both of them are local. And then people of different gender and skills naturally going to make migration decisions incorporating both. So the overall goal is we will try to understand and also try to quantify the sources of the observed kind of the spatial mismatch in the spatial marriage market. So in the first part of the paper, I'm going to show you 3 stylized facts that essentially just summarize our story already. So we're going to call it kind of a conception of broad spatial structural change. So I'm going to show you some trend of the structural change that has some spatial feature. One is kind of an overall educational shift that we see over time. Women get more and more education than men. And second is the overall sectoral shift, is a structural change that's relative to men, more women starting to the service sector. And also on the third one, it also has the spatial differences in the sense that those service sector jobs or occupation are disproportionately located in more developed regions. So relatively, more women starting to the service sector and more into the developed regions. So what that essentially, this is a simple illustration. So you can see that the with spatial structural change, you have undeveloped region, developed region. So some of more of those high-skilled women will migrate, more of them will migrate to the service sector, disproportionately located in developed regions, so going to become here. And then along this kind of a dramatic spatial structural change, what we also find that during the last 15 or 20 years, the social norm in terms of marriage matching is quite persistent. Nothing really changes during that time in the sense that female tend to marry up, finding a spouse that have higher income, higher education, and males tend to marry down. So combined with that, they get to be males trying to marry down, women trying to marry up. So in one end of the location, these low-skilled men are gonna remain single, and on the other region, the more developed regions, high-skilled women will tend to remain single. That's essentially the kind of the simplified story that we're trying to capture. So combine those together, you see the mismatch in the marriage market in both type of locations. You see more low-skilled single men in undeveloped rural regions and more high-skilled women in developed regions. So then in the second part of the paper, we write a spatial equilibrium model that to try to capture what we see in the data and to try to understand the underlying forces. So it's a spatial equilibrium model with multi-sector, multi-skill production, and then migration across essentially across cities. So otherwise, it's going to be standard, and then on top of that, we embed a marriage matching model which following classical joint zero framework. So in each location, there's going to be a local marriage market and local marriage matching. We calibrate the model to match what we see in 2015, and then use the model to do both decomposition and also today I'll show you one counterfactual about the universal marriage subsidy. Okay, so quickly on the results, we find that the gender differences in what I briefly mentioned, those spatial structure change trends along the time are quite important. So if we remove all the gender differences, the national singles rate going to drop by 30% for women. And within that drop, the educational shift roughly explains 1/3 of that. Over time, the women get more and more educated, so there are more high-skilled women overall in the market. That's roughly contribute to the marriage mismatch about 1/3. The rest of them are basically all explained by the spatial differences in the structure change. I'll also mention two of the additional results from that when I get there. That's overall what this paper is trying to do. So first, let me show you some data. This is what we call the grand gender education gap narrows and then reversal. So we see this trend all around the world in many countries, that over time with economic development, more women get higher education than men. So for China's case, that roughly happens after the cohort born in 1985 on the top horizontal axis. So that roughly mapped to 2015 when they turned age 30, that we thought that this roughly the prime age for marriage. So essentially after 2015 in the prime age marriage market, there are more women with college education above than men. If you look at postgraduate degrees, that ratio is even more skewed. Second is about we look at the gender employment gap along the structural change process. So given the time, so let's just focus on the top panel for college educated and above. What we see is that over time, from 2000 to 2015, in the service sector, initially, so this is the gap female minus male, okay, in the employment gap. Initially, there are fewer females working in the high-skill service sector, but over time, there are much more female now working than male working in the high-skill service sector. Look at the trend in the service sector, it's similar across all skills, but most prominent in the high-skill part. We also look at the gender wage gap. Now, I'm not going to show you the detail, but we also see that the gender wage gap narrows more in the service sector and for high-skilled women. Okay, so this is the overall structural change. And then next, we then find there's a spatial differences for that trend. So on the horizontal axis, that's the GDP per capita. So each dot is one city. Okay. We look at both the overall employment in the service sectors, still female minus male. We also look at the net migration inflow. So in both margins, you see in more developed regions on the right, the employment gap or the net migration inflow gap between women and men is higher. So there are more women going to the employment in the service sector, and also then you see more net migration inflow of women. Okay, so this is what we call essentially the key part, the core kind of data patterns in terms of what we call the spatial structures. Okay, and then in terms of social norms, so we look at the marriage matching outcomes. Essentially, we didn't see anything changes during this period. So this we first look at the difference between married people and single people. So if you see, say, in 2015, married men are more educated than single men, but married women are lower educated than single women. So you see the gap in 2015 is basically the same in 2000. And then we look at within married couples. So you see first, for sure, there's assortment matching is the major part. But other than that, there are more higher share of females marrying up to varying a
Sorry for the interruption. From last slide, how much of this gender difference in education years actually attributed to the trend, like female students? I mean, there are much more female bachelor graduates or undergraduates than now on that.
right. So that trend will be there in the background, and then on top of that, if you see the gender the educational gap between married and single.
Yeah.
So this still the gap is still like this. That's kind of the message we try to look at.
So this is not or just for the average education differences between the mix.
No, this isn't raw. So the overall big trend is there.
Okay.
So on top of that, you still see the gap is not changing. So this again, yeah, do you see higher share of females marrying up versus the marrying down? This is related to your question. So you see from 2000 to 2015, seems the share of a female marrying up is declining a little bit, but we're going to argue that's basically more kind of mechanical, that more women get higher education, so there's mechanically less room to further marry up. If you see the share of a female married down, it's 9% in 2000, still 9% in 2015. So that's kind of from the marriage matching outcomes, those patterns, it seems quite persistent. We're going to call it very loosely by the social norm or marriage preference, but essentially just meaning the matching outcomes. So these two dramatic structure change while persistent social norms altogether forms what we see in the spatial distribution of the singlehood. So again, this is the little bit more details look than the map showed in the beginning. So on the left for male, you see the most prominent trend is the blue line. That's the middle school educated or below. So low skilled men, their singles rate is higher in undeveloped regions. And for females, the clear trend is the red line. That's for college educated or above. So for high skilled women, their singles rate is much higher in developed regions. So that's kind of the data, and then basically summarize what we the story that we want to tell.
For the marriage up and down, you were using education as the criteria, right?
Right.
If you look at income as an indicator of whether who's up, who's down. There's high correlation, but I think it's not perfectly correlated with income and education. They're not perfectly correlated.
I agree. I think for income, one issue is when we look at married couples, right? So the females diversify are going to be the issue. So we think this one, the education is more kind of predetermined before marriage matching. So we mainly focus on that. Okay, so for the model, it's a standard spatial equilibrium model. And then we embed a marriage matching model following Chu and Su in each location. So in each city, there are three sectors. Manufacturing, service, and modern sectors, and we're combining skills with different labor. Agriculture just don't care about the skill. You have a set of workers, initially they by different gender, skill, and they start from some location. They will start as single, then they migrate, work in the destination, and then they get a participant in local local marriage market. This can be a static model, so really the timing, we can't kind of think too seriously about, say, whether they migrate first or marry later, or they marry first and migrate later. In the paper, we argue that for our purpose, it doesn't matter that much, kind of a equivalent in a sense, but I'm happy to talk about that during break. But yeah, so that's the timeline we impose in this kind of static model. Okay, so for an individual, if you migrate from city I to destination J, sector K, so this is from I to JK, you're gonna have a overall expected return from in that location sector. I'm going to show you in a minute what's the in that. And then you have we call it compound allocation cost. You're gonna have a migration cost in that, but also kind of conceptually, you can think of this also some cost of finding a specific sector type job in a certain location. So kind of use the term, so add kind of you have a cost of allocate labor to a certain location and a sector. And then you have a location preference shock. Okay, so then it's a standard spatial model, so gravity equation is going to give us the migration flow. If you are married in the destination, so you can pool your income, consume final goods, housing. If you're married, you're going to enjoy some advantage of economy of scale as a household versus two single persons. Then you have a non-pecuniary marital preference. I'm going to show you the scenes in the next slides. If you're single, it's very easy to rely on your own. You have a normalized zero value of being married, being single. Okay, so in the destination, there's a local marriage market. We assume within the city you can match across sectors. Okay, so just one local marriage market per city. If you're married, we assume there's transferable utility within the couples. So in the equilibrium in each location, if you're married, you're first gonna enjoy some value of being married, or you can think this is the reverse of the value of being single in a certain location. They can differ by locations. And then the second, they're gonna be the key part, is the deterministic part, essentially the preference for partner. So given my gender and education, if I match with a type E prime spouse, that's I get some deterministic value from that. The third one is the equilibrium marital transfer. That's essentially the endogenous price that clears the market, clears the supply and demand. So it can be positive, can be negative, depending on your gender, education, and also relative supply and demand in that local market. And then you have a idiosyncratic preference chart. Okay. Production is essentially for modern sectors. You combine different skills level, different level of skills in a CES way. We fairly allow for flexible productivity for each location, sector, and skill level. Housing market is essentially a congestion mechanism. So you prevent people kind of congesting into a specific city, and then the housing price can go up and prevent further migration. So an endogenous equilibrium housing price can clear the housing supply and demand.
I understand you consider a static model, but I wonder whether the dynamic aspect could also be important in this context, because like for the rural people, they usually migrate to the city when they're young, and then return to rural area when they get older. And for rural female migrants, because men marry down, up, so the more likely to get married with older men who get older hukou, so they can stay in the city. While rural men, it's much more difficult for them to marry urban women.
So first, overall, kind of fundamentally, we can't deal with that too much. So what we the view that we take essentially, we look at your realized destination, say when you're an older age, and then essentially we assume that's the final location that you choose for work and for marriage. When the marriage really happens, the very early or later, we kind of think for us is relatively equivalent in a sense. You can think of I start from a location to the rural area, then want to migrate to Shenzhen, for example. If I are meeting with someone who are originally in my hometown, if she doesn't want to migrate to Shenzhen, then essentially we can now match. So that's going to be equivalent. Both of us migrate to Shenzhen first, when we meet in Shenzhen, it's kind of equivalent to we meet in our hometown first and both migrate to Shenzhen. It's kind of the equivalent way to think about that. But I think fundamentally, we cannot deal with that too in a too detailed way.
Third, later stage, for example, before they stay in the area, it doesn't mean that they didn't go to urban area when they were young.
Right.
So they participate in that.
Yeah, fairly later return migration is something we cannot deal with that given the current data. Yeah. Okay, let me
how does the housing market interact with the marriage market?
Several ways. One is it affects the housing consumption as a household versus as single. That will implicitly affect whether you want to find a higher education. Essentially, the education is the same as income in our model. Higher income spouse, so that you say in the expensive Yeah, in an expensive city, right? And then they will may change your incentive to match with a certain level of income spouse or educating spouse.
Yes, I have a question about identification, because if from Chu and Xiao, like we can only identify the.
I'll talk about that. Yeah, I'll talk about it. Yeah. So, okay, data, I think I don't want to talk too much. This is essentially the 2015 data we will try to match what we observed in 2015. Yeah, I'll quickly about the identification. So essentially our model have two layers. You have an inner loop equilibrium that's in each location, we need to solve the marriage market equilibrium. So that, how we identify this, all of those terms, is we observe the local marriage market equilibrium across different locations. So we have multiple market data. So that's something like you do in IO or marketing. You identify both supply and demand using data from multiple markets. So that's the way, kind of the brief answer about how we identify those terms in joint soup. If you have only one market, then you can only identify up to the entire thing. So outer loop is a spatial equilibrium model so given the expected marriage market equilibrium in each location, then people make migration decision to solve the outer loop migration gender equilibrium.
Yeah, my further question is, do we to somehow assuming the state rule or sharing rule, that the constant and the y is relatively stable across different places?
The preference is the same.
Not preference, but essentially, like I guess intuitively my question is, if you think about different places, like some place marry down and some place marry down even more or marry up even more, but intrinsically for each individual, they may actually need to sacrifice or gain surplus from their spouses if they married up or married up, right? And if their like local marriage market condition is different, eventually what they gain would be different depending on how much their demand is or how much the relative supply is.
Right. So
I just feel like there's some kind
of so what we assume is the preference, the marrying up or down preference is the same across locations, and then everything else reflected in the observed matching outcome is through the relative supply and demand, and use the endogenous transfer to clear the market, to clear the supply and demand. Okay. So that's a kind of assumption. So it could be something else going on, but all those variations are reflected in the, we just treat them reflected in the endogenous transfer. Okay, so we can fit the spatial distribution of the marriage market, the singles rate by gender, by skill fairly well across locations. Given the time, I'm going to show you some key parameters that essentially reflect how our models try to understand or map what you see in the data. So this is the marital preference. Just highlight two numbers given the time. There's some details on that, but overall, what you see for low-skilled men, relative to being single as a value of 0, they really have a quite negative value matched with high-skilled female. And then on the opposite, for a high-skilled female, marrying a low-skilled male is something negative. So that's what's reflected in the marry up or down preference. And then lastly, the key part of the allocation cost. So once we recover the model and then get the detailed the overall allocation cost, tau ijk, we decompose that into first a distance function. That's essentially a migration cost. And then there is a average sectoral allocation cost just by k. So that captures essentially the relative cost that you find your certain job in a certain sector. Lastly, is essentially the residual epsilon that captures the further spatial differences conditional on those average sectoral costs. Okay, that can differ by gender and skill. So for the overall sectoral cost, what do you see? Let me just highlight the high skill female. So for high skill female, the cost is the lowest working in the service sector, and that cost is also lower than high skill men. It's on average working in the service sector. And then across locations, for high skill females, cost is also lowest in the most developed regions. That cost is also lower for high skill males in the most developed regions. So that's the relative spatial differences in terms of for female relative to male finding a high skill service job in developed regions. Okay, so with those, we first do a kind of decomposition. So what we do is we try to remove the gender differences in all those three shifters. One is we equalize the educational level between men and women. Second was we equalize the tau K, the overall sectoral allocation cost between men and women. Third one is to remove any gender differences in across locations. So we do that one by one and also all together, so you see the decomposition. Let me just focus on the female side. So removing all the gender differences is going to drop the women's single rate by roughly 30%. It's more even higher for women in developed region for high school women. In terms of decomposition, the educational trend, the education gap reversal roughly explained 1/3, and the spatial differences essentially accounting for all the rest of them. Overall, structural change doesn't explain much about the spatial mismatch in the marriage market. The key reason that we argue that it does not touch anything on the spatial differences. So overall trend doesn't contribute to what we see in the mismatch in the marriage market. Second is very simply, we linearly project those trends between 2000 and 2015, and we go for the future for 15 years. So that's with a simple projection of what's happening in 2030 for China. Essentially, all those trends continues, and then you see a much higher increase in the national singles rate, and especially for high school female in top regions and low school male in undeveloped regions. Lastly, is we simulate one universal marriage subsidy that equals to 10% of lifetime income. So it's given the current China's GDP structure, that's roughly 3.5 of annual GDP per year. So it's a huge physical burden, but it's not crazy. So if you compare this GDP, 3.5 GDP, that roughly is what Nordic countries are currently doing if you combine all their family policies. So anything related, because we only have marriage in our model, so anything related to fertility, couples taxation, for example, or anything related to a household versus a family versus a single, you can think of is there. So it's a big policy, but not crazy, we think. And we find it indeed, for sure, it drops the singles rate a little bit, but you see the size is very small. The idea is a universal pure monetary subsidy does not change any of the fundamental spatial mismatch in the structural change process and is reflected in the marriage market. So that's the main message we find out sadly. So let me quickly conclude. So we developed a spatial gender equilibrium model that has a local marriage matching part in that as well. And then we can closely match what we see in 2015 and over time, the time trend. And through the decomposition, we find the spatial differences in terms of the structural change over time is the most important factor contribute to the spatial mismatch in the marriage market that affects both the local marriage market, marriage rate and aggregate. Yeah, thank you very much.
In the last slide, when you do that counterfactual,
yeah,
10% marriage subsidy, do you allow the location decision to respond to the?
Yes. No. Yeah. So allow for all the responses. Essentially, another result.
So this effect is this subsidy is not effective in changing that location for it.
Right, not much. By the way, I want to see the money is coming from nowhere. It's not from the balanced budget. So you can think there's an even larger policy effect in principle, but still we found that smaller. Yeah. The idea, I guess, if the location specific marriage subsidy may potentially work, but also that has to target gender as well. And then politically, in the feasibility is going to be an issue, perhaps. But that's the overall message. Thank you very much.
Have you ever considered some kind of like equalizing skill specific mobility cost, which is really reflect like a Google system in China? How do you think about
I see. We haven't looked at that. The pure migration cost essentially. So we can for now we focus more on on those labor market allocation costs. But I think we can look that as well.
Well, do you think it's ever like model?
I think for sure, if anything is gender specific, it's gonna affect to some extent, but how large that is, I'm not sure. Thank you very much.
We have done about you. Good morning, everyone. I am Dan Han, PhD student at Korea University. And today I would like to present my work on workers' dynamic decisions on crowdsourcing platform. Specifically, I study learning by doing effect. And let me begin with the motivating example. Yeah. So suppose a worker completes several tasks on project A and becomes faster over time. Suddenly, a new project B appears with a higher price. Should she stay benefiting from learning or switch, chasing better pay? So here you can see an example of this project. For instance, you are doing image classification tests. You did 15 tests for project A. Here you can see it. Average completion time is 12 seconds per test, and let me show here. And 92% of accuracy. You see that each test gives you 10 pennies, and second project B gives you 18 pennies. Although you have accumulated experience on project A, you may get more for doing tests on project B. So there is conflict trade-off between staying and switching on the same project. Staying gives you learning by doing effect. So doing similar tasks on the same project increases productivity. Workers should do some training tasks before doing real tasks that give pay. So there are some sunk training costs that are already paid. Also, switching can be beneficial for workers because it can give higher prices or better project features. Although worker by switching the project loses accumulated experience, and she should do some new training tests, and it leads to higher short-term costs. Key implication here is that retention is not trivial, and it reflects forward-looking optimization. So why retention matters and why dynamic structural model is needed? Retention matters because experienced workers produce faster output and requesters benefit from consistent label data. So as you know, there is a platform network effect. As there are more workers in a platform, they produce and they retain to the same project. They produce faster output. It is beneficial for requesters. So there are more requesters in the platform. If there are more requesters in the platform, there are more tasks, and it bolsters the number of workers again. So there's a vicious cycle in a platform which increases platform efficiency. So platforms avoid retraining new workers and maintain stable quality. Retention also is a dynamic choice. That's why we need dynamic structural model here. And I study learning by doing effect, which lowers future costs. It means that a worker does tests in a same project, and it reduces average completion time. Switching results experience and induces short-run costs. So task attributes shape forward-looking incentives. Implication is here that dynamic structural models is required to quantify learning, experience, and switching costs.
Although learning by doing is good, empirical data shows that workers switch quite early. So workers often open and consider multiple projects within a session. Session here is an analog to a working day in traditional labor market. So I define session here as a working day of online worker. With new session starting if more than 1 hour is passed after I did the last task. So median session includes 2 projects, but each project receives only 1 task. What does it mean? So for instance, you see this kind of 2 browsers here. The median worker opens 2 browsers. And first, he does project A, audio transcription task, for instance. He does it, and then, oh, I think I'm bored. And he does a second project task. And then again, he goes to project A and does it. And again and again, he switches the project. But overall, in one session, he does 2 projects. So workers sample projects shallowly and switch very early. And this early switching pattern motivates a dynamic structural model to quantify experience and switching costs, to increase retention rate of workers, and therefore to enforce the platform efficiency. So here is just a figure that shows that workers usually do 1 task and then switch to another project. So let us move on to the overview. I aim to cover what factors influence platform workers' incentive to continue the same project or switch to another project on the crowdsourcing platform, and how does learning by doing affect labor supply costs. I utilize reduced form analysis with profit models to study short-run effects, and then I use dynamic structural model to study long-run effects and run counterfactuals. I contribute to dynamic labor supply models by extending this framework to microtask platform workers. Also, my work is related to online worker motivation models. Prior work focuses on static incentives like payments, and I study long run or dynamic learning by doing behavior. Methodologically, my work is based on the classical discrete choice framework by Rust 1987 and Hudson Miller and Aguirre and Mura and etc. So here are results summary. Reduced form analysis shows that workers tend to repeat similar tasks, and task attributes and demographics significantly affect continuation. Structural model findings illustrate that workers have non-refundable experience costs. So there are some project-specific training costs in the platform. Project here is similar to an analog to job in the classical labor market. And workers learn by doing. There are some short-term costs for repeating it. There is a decrease in costs for repeating a task. Also, learning by doing effect is present for complex tasks too. So I define here a complex task as a task with an average completion time more than 5 minutes. So learning by doing also works for this kind of complex task. So I think maybe I had to start with explaining what's the crowdsourcing, but let me do it now. Crowdsourcing is a term that combines crowd and sourcing. So crowd means a large group of people, and sourcing comes from outsourcing. Crowdsourcing differs from outsourcing because it often does not need professional knowledge or skills. So crowdsourcing involves breaking down a big project into small tasks or micro tasks. Workers distributed over the internet do this kind of tests. The analog is Henry Ford's car company, when you build like a car. And here you can see some project types. So for instance, you may have filling out service tasks or classification tasks, web searching task, content moderation, or task for audio transcription task. Data source is one of East European crowdsourcing platform, big data that accumulated every second. And overall, I have 1,000 projects, 60,000 workers, and 7 million assignments. There are 4 data levels: worker, project assignment, and session levels. Here, assignments are equivalent to tasks. Okay. And in final sample, I include workers that are not occasional visitors and which are not bots. For assignments, I use only browser available assignments because there are not only browser available tasks, but smartphone available tasks. But if I include smartphone available tasks, then I have to also include the decision to switch the devices, not only the projects. That's why I use only browser available tasks, and they consist 70% of total data. So I think browser available assignments are representative, and I use only submitted assignments. Time frame is 1 week, as it is big data. From October 1st to October 7th, 2021. And let us see some results from reduced form analysis. Evidence 1 shows that workers tend to do similar tests. You can see here summary statistics for session characteristics. As I said before, within a session, worker performs 2 projects. So not that much in a working day. And second evidence is that demographics matter, and age, higher education, English skills influence the likelihood of continuing the same project. Although gender or experience here is the number of months from the registration date. So these 2 variables are not explaining the change of likelihood of continuing the same project, but some age that maybe show the digital proficiency, some kind of, and the university degree and ability to speak English, which may be processed for general skills. They matter and they increase the likelihood of continuing the same project. I can interpret it as general skills increasing resilience to the doing the same tests. Third evidence shows that assignment completion time decreases. That is, productivity increases as the number of tasks increases. So here is the key evidence that I use for saying that there is some kind of learning by doing effect. Completion time when worker perform 1 task is 3 minutes. For 2 tasks, it decreases by 1 minute, and so it is 2.2 minutes. From third, we can see that decrease is smaller, but still there is some decrease in completion time.
So, there seems to be a quantity quality trade-off, so the grade is also falling with the time.
Oh, yeah.
I mean, I guess I'm just trying to think, it's learning by doing, shouldn't the grade be at least constant?
Yeah, it's kind of hard to quantify the learning by doing effect. Well, it is it's quite hard to interpret for me like, this grade for now.
Does your model incorporate this grade or the quality of the work, or is it just focused on?
I included as a control variable as a pleasantness, but I make it a binary variable. So if median project grade, if the project grade is bigger than median project grade, then it's 1, and if not, it's 0. I just did for computational burden. Yeah. Yeah, I think it's a good question. I will consider further about it in my future studies. Yeah. But you can see that other variable price per minute increases, for instance. Yeah. Last evidence shows that price, training, rate, complexity influence the likelihood of continuing the same project. So here you can see positive, significant coefficients in front of price variables, and the training also increases the probability of continuing the same project. Project rate also increases. Although task complexity decreases the likelihood of continuing the same project. So we saw some short run statistics. Now we move on to dynamic structural model. Let me begin with a setting. Crowdsourcing platform workers complete tasks on various kinds of projects. And we model the project's switching decisions. I represents a worker, and T indexes time. At time T, worker I has state S and action A. There are observable state variables X and unobservable state variable epsilon. Every period T, the worker decides to switch projects or stay on the same one. So here is utility stay function. And profit function contains 2 variables. Project rate, which shows the pleasantness of the project, and it is equal to 1 if project rate is higher than the median rate, 0 otherwise. And paid task price distinguishes 3 price categories. Most of them are really cheap, 1 penny per task. And second category is from 2 pennies to 5 pennies per task. And third category, 6 pennies per task or more. Second part of the staying utility function is the continuation cost function. It contains 4 variables. First is training, the existence of training or examination tasks in a project. And these training tasks are project-specific training tasks. Task complexity is 1 if the average task completion time is over 5 minutes and 0 otherwise. Number of completed tasks show a learning by doing effect, and there is some interaction of task complexity and number of completed assignments that show how workers react to the task complexity change with experience. And
so you mentioned the grade is the pleasantness. So is that the quality of the task force is actually rated by the worker itself, more enjoys testing?
yeah,
So
if
they
they
precise. What do you mean by the pleasantness of the grade?
yeah, I understand. So it's some kind of just the grade that you see. I wanted to just show this kind of project rate that you see before completing task. Yeah, yeah.
Okay, so this is given by the worker. It's not a review of the worker's performance.
Yeah, it's a project rate, not the worker, how workers did, but how project is good for worker. So I do this project and then I may rate it. Yeah.
Now this may explain the first question about looking to that. So this is not the quality, it's that as a worker in more task can get bored. Yeah.
Oh, maybe.
Yeah, I think I misinterpreted grade. We can move on, but yeah,
Okay.
I thought it was a quality of the task.
Actually, in my data, there are no there are no quantitative measure to measure quality. So I use only average completion time to measure the learning by doing effect. Okay. And it's the last part. Switching utility function. It contains two parts. The fixed switching cost. For instance, it's some kind of searching cost in traditional labor market, job searching cost, or like other type of costs. And E is the loss of past experience from switching to another project. Yeah. It's measured by the existence of training task in the previous project before switching. So this is the overall formula. You may see epsilon state and epsilon switch are unobservable state variables. Okay, so you can see it's just standard procedure of doing running Bellman equation, and we estimate the structural parameters using the nested fixed point algorithm, which is also standard in dynamic labor supply models. So for results, we can see that raising the monetary reward and creating a pleasant and high quality project environment increases workers' staying profit. You can see positive coefficients here. And also we can see that training and learning by doing lessens the cost of staying on the same project. So adding training and assessment tasks to projects is beneficial, and also including more tasks in project is also beneficial to retain workers. And you can see that complexity increases staying cost, but interaction of number of tasks and complexity decreases. So dividing a complex task into simpler tasks will decrease the worker staying cost. Here you can see switching cost functions, and policy implications here are that switching costs are low, but the loss of past experience, that is training on past projects, increases them.
Okay, so this, what do you assume to be the expectation about the future arrival of future projects in this decision?
About future
Future projects. So the projects arrive stochastically, I guess.
Yeah.
Some pay more, some than others, some are more pleasant than others. So what is the assumption that you are making these workers when they make the decisions regarding future projects?
Assumptions.
This is a dynamic problem, right?
Yeah.
So maybe have expectations about the GDP mentioned.
Or you already know everything that's out there.
Yeah.
Maybe you're thinking more in a way where you already know the population of possible projects, and there's nothing as stochastic like the name is asking about.
Yeah. I think I don't know the theory here, so yeah.
Can you show the value function of this? Yeah. So what's that expectation of? Oops.
Here means
Yeah, expectations. X prime and epsilon prime.
I'm here is just Markov searching. Yeah, afterwards, let's discuss it after. Sorry. Okay. So this paper sheds a light on the crowdsourcing platform workers' dynamic choice in undertaking tasks. It studies the determinants of the labor supply decision, focusing on learning costs. and gives policy recommendations regarding price, training, and test complexity. For further research directions, I may consider some demographics. For instance, I did some heterogeneity analysis for higher education group, but I may show if there's some time left. And the counterfactual results also. I want to also add other decisions like leaving the platform or unsubmitting, and etc. Also, I may extend the period for increasing consistency and the variable space. Thank you.
You have
So, you described several types of things like classification were some of the examples, but there was also a transcription. So in your data, are people switching between those large classes?
No. So there are project types, and then inside there are like different projects. So as training tests are specific to projects, so if you switch a project, you should do another training test again. So that's why I studied project switching decision, not project type switching decision. Yeah.
Because I guess what I've been trying to think through is, it seems like some of the learning could be transferred to another project of a similar type. Like if I can classify cats, I can classify dogs, because I've learned what per animal. And I was trying to think through in your model, I didn't see any like kind of similarity measure between what I'm switching to versus my current content. But
I think it's a great point, and I may add it to further future work. Thank you.
Right. Okay. Thank you so much for coming to the session. So I'm the last speaker, Meijia, and you can see that my talk has nothing to do with labor or marriage. That's because the original speaker dropped out in the last minute. So I would have to cover it as well. So I hope I can entertain you for the last 30 minutes before lunch. So this is an old paper with Streamson, but we are revising this intensively recently, so I hope to get your feedback. So the paper talk about the altruistic motive and exchange motive using evidence from the effect of health, children's health shock on parents' intra-household resource allocation. So when parents distribute the family resources, we often observe that they kind of show favor to a particular child. So there are two possible explanations for such a parental behavior. One is the altruistic motive. Parents may care about the well-being of their children, while the other is the exchange motive, where parents provide investment to their children and expect that children will pay back by providing other care when parents get old. So these two different motives have very different implications on family resource allocation, such as how parents decide education investment, monetary transfer, and even the elder care arrangement. At the same time, it also has very important policy implications, especially for those public policies that aim to redistribute income. So if parents mainly have the altruistic motive, then the public transfer from the government will be crowded out by adjustment in the private transfer. This is because the parents already kind of achieved this more optimal level of investment. On the other hand, if parents have exchange motive, then such neutrality result will not hold, then there will be room for government to step in to improve the welfare of children. So previous studies try to shed light on parents' motive by looking at how they respond to children's endowments. So actually, Jay talked a little bit about this reinforcing versus compensating strategies. So actually, the literature find here's Jay. Literature find very mixed results about how parents respond to children endowment. I was talking about your paper yesterday. So some find that the parents use reinforcing strategy by investing more in the advantaged child, while others find parents use compensating strategy by providing more resources to the less advantaged children. Moreover, a few studies also find that parental responses could differ by their socioeconomic state. So in this paper, we try to understand the following questions. First, how do parental investment and transfer respond to children's health shock at early age? And also whether their responses differ by their socioeconomic status, which is measured by the education levels. And moreover, we want to understand what are the underlying motives that drive such parental behaviors, whether it's driven by the altruistic or exchange motive or both. So the first part of the paper tried to provide some empirical evidence that document parents compensating or reinforcing behavior using Chinese twins data. So here we analyze how parental health shocks could affect two types of decisions. One is the educational investment, and the other is the monetary transfer. And we actually show that the parental responses could be very different between investment and transfer. And then we also document that the parental behaviors actually differ substantially by their education levels. And then we try to reconcile these patterning patterns by using an intra-household resource allocation model, which incorporates both altruistic and exchange motive. And first, we show theoretically that the model with single motive cannot explain these heterogeneous responses between low and high educated parents. And then we use estimate a model and then use simulations to show the relative importance of each motive among the two types of parents. And then we conduct counterfactual analysis to show how a public subsidy to children's education could have differential effect between low and high educated families. So we utilize two twin surveys, adult twin surveys and child twin survey. So Jason conducted both surveys. What we find is this diverging patterns between high and low educated parents. We find that for high educated parents, they reinforce in investment. So they provide more education investment in the healthy child. While at the same time, they also compensate the unhealthy child by providing more transfers. And for low educated parents, we find that they actually reinforce in transfer. They provide more transfer to the unhealthy child. And in terms of educational investment, we don't find a significant difference between healthy and unhealthy children. Then we develop a model that incorporates both motives. And then when we estimate the model, we find that the behaviors of high educated parents are mostly driven by the altruistic motive, while that of low educated parents are driven by both motives. And I'll talk about the rationale behind that when I get to the model. And then in the counterfactual analysis, we show that the public education subsidy will be crowded out by a reduction in private investment. And this effect is especially stronger in high educated families. And moreover, there's also an unintended spillovers to the investments in healthy child and also increase the transfers to both children. And this will in turn increase the welfare of not only the target child, but the untargeted one. But overall, the effect is stronger in low educated families.
When you talk about exchange motive, does it matter what is the parent trying to exchange? Like, is it financial transfers
Mm.
or care time?
We consider both. Yeah, we consider both the time and monetary support. Okay, for the sake of time, let me skip the literature, directly talk about the data. We use 3 data sources. So first is the adult twin survey. This cover around 1,500 pairs of adult twins in 5 Chinese cities. Survey was run in 2002. This survey allows us to observe lifetime health status of these twins, as well as the wedding gifts parents provide to them when they get married. So in context of China, wedding gifts is kind of one of the largest amount of transfer parents provide to their kids over their lifetime. And we also observe the elder care these adult twins provide to their parents. And we define a measure of early health shock, which is an indicator of whether these adult twins have any of the following diseases before age 18. So the top 3 categories include migraine, rash, and disability. Then we move to the child twins because in child twin survey, we can observe health and also importantly, parental investments on these kids. And then we try to also provide a similar measure on early health shock, which is an indicator of whether these twins has any of the following diseases up to the survey time. The top 3 categories include diarrhea, calcium deficiency, and asthma. And then we also complement these 2 data sources by using the child's data because it provides us with not only information on time support, but also monetary support. We also observe the wedding gifts parents provide to them. And then we also have much larger sample size from child. Okay, so the reduced flow analysis is very simple. It's just a very standard twin fixed effect model. So basically, we regress a bunch of outcome, the difference between the twin pairs on the difference in their early health status. And by doing that, we can kind of rule out some of the confounding factors that are common across the twins, such as parental endowment, family environment, neighborhood, etc. And we define parents' socioeconomic status based on their educational attainment. So we classify parents into 2 groups. High educated parents are those with junior high school degree. So this shows the baseline results. Here we can just focus on the last 2 columns. We find that in families where parents have less educational attainment, actually parents provide more wedding gifts to the children with good health. So in particular, the healthy children receive 31% more wedding gifts compared with the non-healthy one. Whereas in high educated parents, we observe the opposite pattern. So actually, the healthy children receive 32% fewer wedding gifts compared with the unhealthy one. In terms of the education investments, we find that among the low-educated families, parents do not invest differently between healthy and unhealthy children. So this coefficient is not economically or statistically significant. While for high-educated parents, they would invest more in the healthy children. So investment is 11% higher. Then we also look into how health shocks affect other care arrangements. So here we find that in low-educated families, healthy children are responsible for more elder care services. So this is suggested by a higher chance of taking care of parents and also a higher likelihood of living with their parents. However, we don't find significant result in higher education.
Co-residents literally living together or living in the same family?
Living together in the same house.
Do you have measures about not necessarily living in the same place, but nearby?
Right.
A lot of the care I know there's panel A that's we can directly into but co-residence may be extended a little.
Sure, yeah, we can do a little check for that. Okay, to summarize the reduced form findings, we find that the high educated parents, they reinforce in education investment, compensate in monetary transfer. Whereas for low educated parents, they reinforce in monetary transfer, their education investment do not respond to children's health shocks. And also, the low educated parents, they rely more on the elder care provided by healthy children, while there's no such pattern in high educated families. Okay. And we did a bunch of robustness checks, like we try to make sure the health measures we use are really like a random shocks. So this is not driven by some endogenous parental investments that differ between the twins. And we also further include birth weights to control for this difference in their endowments. And we also rule out the possible explanation that health shock could affect their marriage outcome, whether they get married, so that could affect like the wedding gifts, and also who they married to. And also we use alternative definition of socioeconomic status. Instead of using education, we use income and find very similar.
Last question. Do you have any information in terms of whether siblings help each other or how close they are?
Yeah, unfortunately, we do have, but this is not the focus of paper. So Jensen and Rufei, I think we have another paper that look at the help between siblings. But here we focus more on the interaction between parents and children.
So, but how much is about the different motives versus financial constraints for low-income families to spend more for health?
Yes, that's a valid concern. In the model, we take that into account. So we allow parents with different education to have different income levels. And then in the theoretical part of the paper, we show that even if we take into account financial constraint, the single motive cannot explain these packaging. Okay. So let me talk about the model. So this is the timeline of the model. We have parents and children. Each. Yes.
Do you have anything about the gender composition of the twins?
Right. So we focus on same-sex twins in this analysis because the adult twin survey basically only sampled the same-sex twins. Because when they try to look for the twins, it's much easier to detect the same-sex twins. And we also check whether the results differ between the boy twin pairs and girl twin pairs, but we don't find.
And the wedding gifts are like traditionally more common for boys or girls?
I think it's for both, but they serve different purposes. For boys, it's mostly called bride price. It's the price paid to the bride's parents. For girls, it's like dowry more given to the young couple. Okay, so then each period, there are two periods. Each period lasts 20 years. So for parents, the first period is from age 30 to 50. They will make decisions about this education investment YI, monetary transfer BI to each child I, and they also make saving decisions. And in the second period, parents retire, and there's a chance that the parents will get sick, and then children will provide time support TI and monetary support MI to their parents. And parents differ in their education level J, so there are two types of parents, low and high. So this is a model, very simple. This is the CM is parents' consumption when they're at the middle age. And the first period parents face a budget constraint. So IJ is parents' income, so that can capture the difference in their budget constraint. And then parents will kind of allocate their income between their consumption, education investment Y, the monetary transfer B, and also savings K. And in the second period, there are two possible scenarios of probability 1 minus PJ, parents are healthy. So if that's the case, then parents simply consume their savings, and children, they will just consume their wage income WI plus the monetary transfer they receive from parents, BI, and then there's an interest associated with that. And then parents could be altruistic towards their children. So that is captured by the parameter delta J. Children's utility UC1 and UC2 will enter parents' utility function with this CES functional form. So rho capture the inequality aversion for parents. And if parents are sick with probability PJ, then in this case, children will provide time support and monetary support. So there's a utility coming from the time support provided by children. And for time support, not only the quantity matters, so T1 and T2 matters, but also the quality. So Q1 and Q2 measure the quality of time support. In particular, we suspect that the quality is higher for healthy children. So that's why in low educated families, we observe that it's more likely the case that healthy children are responsible for elder care. And then parents can also receive monetary support. So you can see their consumption, COU, is affected by M1 and M2. So children provide transfer to their parents, and parents also need to pay a medical cost X. So when parents are sick, they could still care about children. So there's also a delta term there associated with their altruistic mode.
If the parent is healthy, then no transfer from the children.
Right, that's a kind of assumption of the model, but empirically we also observe this is likely to be the case. So for parents who are sick, we observe that annual transfer is around 800 RMB, but for the healthy parents, the transfer is around half. Yeah, but that's a simplification function. Yeah. Then children's education can be produced using parental education investment Y, and also is produced using their own health H. And parental education can affect the production efficiency. So that's reflected by AJ, so with this J subscript indicating parental education level. And then children provide two types of OJ support. Time support and monetary support are both affected by children's education, EI, and also the parental transfer, BI. However, these two factors play very different roles. For children's education, it actually reduces the time support because it increases the opportunity cost of providing time support if children are more educated, but it will increase the monetary support. For parental transfer, it can increase both time and monetary support because it can kind of cultivate the children's altruism towards their parents. And then there's a mapping from education to parental earning and children's learning. So now let's think about a simple case where we only keep the altruistic model. So this is the case when we set PJ, the probability of being sick, to be 0. So the prediction of the model is the following. First, the ratio of optimal education investment is a ratio of children's health status. So this kind of implies that parents will invest more in the healthy child. This is because if you think about the production function, this is Cobb-Douglas. So it implies that the investment in children's education increases with their health status. So they want to invest more in healthy children because this is more efficient. At the same time, parents are altruistic, so they also care about equality. So the optimal consumption level of the children will be such that they should have equal consumption. So then parents need to compensate the unhealthy child by providing more transfer. So this kind of implies that there could be an different prediction between investment and transfer. Because for investment, there's a return. So it depends on your health status. Well, for transfer, $1 you give to the child will receive $1. So there's a 1-to-1. So in order to be efficient, parents want to use the investment in the like a more efficient place, which is on a healthy child. So you can see that this prediction actually in line with the behaviors of high educated parents pretty well.
What should I think about, like, usually people will have more sympathy on the weaker person?
Right, that's a good point. So for now, we assume parents are symmetric. So it's really, yeah, we're still thinking how we identify the sympathy parameter. So that would be a bit tricky to capture. So, but the point is, even if parents have sympathy towards a specific child, it's still difficult to explain the behavior of low-educated parents using just the altruistic motive, right? Because then they would just show that it would just provide even more transfer to the unhealthy child. Okay, and then what about the model with just exchange motives? So in this case, we know that healthy children, they can provide high quality time support. And because they're also wealthier, they can provide more monetary support. So parents should provide more transfer to the healthy child if what they care is the elder care. Yes.
So if they are able to observe the parents' time support to the unhealthy group.
Time support to the unhealthy group.
Yeah.
We can observe the education investment and the health investment on both children. So there's another paper by Jun Jian and Jean Heckman and co-authors. They show that actually for health investment is quite different. So parents actually compensate providing more health investment in an unhealthy child. But that's understandable because of this health status, we usually need to spend more money there. Yeah, but that's not the focus of this. Okay, and then we talk about the transfer and how about the education investment. Now parents actually face a dilemma. So basically, they know that it's more efficient to invest in a healthy child, but they also want to keep this healthy child providing time support. But they know that if the healthy child becomes more educated, maybe they will move to other places, right? So they will not be able to provide time support. So they want to suppress a little bit of the investment. So in this case, there will be ambiguous prediction on the investment. So it's possible that parents do not want to provide too much investment in a household. So that would be consistent with the behavior of low-educated parents. All right, so then we bring the model to estimation. We estimate a bunch of parameters. In particular, we want to understand the altruism parameter and exchange motive parameter for low and high educated parents. And then we estimate the model using 2 steps. First step, we estimate the children's response to, in particular, the time support and monetary support outside of the model. And then the second step, we estimate the rest of parameter using simulating method models. So this is the elder care production function. We use Charles data. So you can see that I just described the writing gifts can improve both time and monetary support. So increase the chance of whether children provide time support, whether they live with parents, and whether they provide monetary transfer and amount of transfer. While for education, we actually find this opposite prediction. So high educated children, they provide less time support, but more monetary support. And this is a mapping from education to earnings that I will skip. So we estimate the rest of the parameter using several moments. This includes the levels of education investment, monetary transfer, time support for 2 types of parents, as well as the differences in this outcome between healthy and unhealthy children that we obtain from the twin fixed effects estimation.
So the previous slide was not using English, it was using charts. This
Yes.
is not twins, right?
Yeah, that's not twin. Unfortunately, the
But you have a family fixed.
right, I have the family fixed effect try to kind of rule out these confounding factors. So it's within the family, like one sibling receive more writing aid than the other, how that affects their.
The observation really change very a lot depending on what's the reason.
Right, because for the first question, only the unhealthy parent would answer that question. Only parents need help. And the last one is conditional on those that provide the monetary transfer. So 3 and 4 is also a little different because 3 is everyone, 4 is
Zero was not.
yeah, 0 is not. Okay. So let me show you the results. So first we find that both low and high educated parents care about their children. So their altruism parameters are kind of similar, but what's more surprising is that the probability of needing help or the exchange motive parameter differ dramatically between the two types of parents. So for low educated parents, it's 0.95. While for high educated parents, only 0.21. So this kind of reflect that when they make this investment transfer decision, what's their expected probability of expecting that children pay off in the future. So this may not kind of map exactly with the realized probability of being sick. It's kind of just reflecting their expectation. And also we estimate the quality of time support, and indeed we find the quality is higher if the support is provided by a healthy child than unhealthy. Okay, so now let me get to the simulation. So we basically consider two scenarios. One is to shut down the exchange motive, and the other is to shut down the altruistic motive. So we normalize the baseline level of investment transfer to 100 and look at how shutting down one motive affects the parental decisions. So first finding is that the education investment is mostly driven by the altruistic motive. So actually, if we shut down the exchange motive, we will see even higher investment. That's because due to the exchange motive, parents don't want to invest too much because too much education will reduce the time supply. And in terms of monetary transfer, we can see that for low educated parents, both motives can explain a pretty large share of the transfer, while for high educated parents, the transfer is mostly explained by the altruistic motive. And then we also consider a hypothetical policy counterfactual where governments want to subsidize the education of unhealthy children. So in this case, we actually find first there's a crowding out effect on the education investment in child 2. So child 2 is the unhealthy one. And the crowding out effect is especially larger among the high educated families. So this is because the high educated parents, they already reached their optimal level of investment because they are altruistic. While for low educated parents, their decisions are also driven by exchange motives, so they would kind of underinvest in their children. And then we also find a spillover on the healthy child. So parents, when they can save money on the education of unhealthy one, they would spend more on the other kids. And again, we find this spillover is larger in low educated families. So we also see that there will be kind of a spillover to the transfer as well. And actually, I also find that there's also an effect on the time support provided by children, but I don't have time to show here. But overall, we find that the increase in education utility are much larger among the low educated families. Okay, so let me quickly conclude here. We use 2 twin surveys in China and find that parents with different education level respond differently to children's health shock. And our finding shows that low educated parents, behaviors are driven by both motives, while high educated parents are mostly driven by the altruistic motive. This suggests that there will be more rooms to improve the welfare of low educated parents. I'll stop here. Thank you.
Question? You want question?